Hello, everyone. How's it going? So, welcome back to episode 2 to this Lex Code of Saikyo, the language learning app. So, last time, where did we leave off? We left off when we were in the middle of making a window, and, well, basically, nothing happens. We just spin forever and nothing appears on the screen. So, we're going to fix that up today, and we're also going to um, well, I don't know. We'll figure out what to do after that. I do actually know, but um, just the order of things is interesting. So let's go ahead and make it so that this window will appear onto the screen. So the problem is that we're not accessing the event loop. So basically what happens is that we come through, we make the window, and we're waiting for the window to appear on the screen, but we never give Appkit the signal to actually show it on the screen because if you remember when we looked at the documentation for NS application, it said that as a part of initialization, it would also connect to the Windows server. And the Windows server on macOS, uh, what you can do to look at it is I think I have, well, if you look at Activity Monitor, there's a whole bunch of obviously things that are running. God damn, 31 gigabytes written. Okay. I was going to say if this is disk, if Google Chrome was 31 gigabytes, that would be ridiculous. How much memory is it using? Okay, only 281. Okay, not terrible. Not terrible. Sea Lion is a freaking Sea Lion is ridiculous. Where'd it go? Memory. See, this is why you don't want to write things in Java because you get this kind of craziness. Why a text editor? Uh, sure, it's a smart text editor, but why it's 2.4 gigabytes memory hungry is crazy. Actually, no, I'm not being fair. That's because I've set the JVM for my C-Line instance to be 2 gigabytes, 2048 meg. So probably this has just been pre-reserved. So you know what? I was wrong. Never mind about that. But if you look at all of the processes that are running right now on my Mac here, and there's a ton of them, there will be one, if I can see it, I might be able to just quickly jump to it. No. There is a, actually, we'll go here. There should be a process that's called underscore Windows server. Let's see if we can see it. Maybe not. I don't remember if it's hidden or if it's shown in the. Did I just go past it? No. We may not be able to see it, but the point is that in a separate process somewhere is the Windows server for macOS, and I haven't looked completely into the details, but what it and so many other programs like it do is essentially every window that is created on your computer talks to the Windows server to get some memory from it. I can't see it. To get memory from the Windows server, then each application draws its stuff into the window buffer that they get back, submit that to the Windows server, and it's the Windows server which ultimately decides the final composition of the desktop. So there's going to be a buffer somewhere that's drawing this top window, this the what do they call this, the activity bar or something, whatever that is. Obviously, Chrome is going to be drawing itself. If we had other windows, if I open Finder, for example, Finder gets a buffer from the Windows server and it draws into it, and then the Windows server will go ahead and draw first Finder, then Chrome, then I guess this, maybe. Also, the drop shadow may actually be a part of Finder, actually. I think the Windows server doesn't worry about effects like this, though I could be wrong. But that's basically what the Windows server does. And the way that the Windows server kind of talks back to your application is through this event loop. So we need to go ahead and we need to service the event loop at reasonable times. And for mobile applications, kind of the primary difference I would say between mobile applications and desktop applications is the same difference between a library and a framework. A mobile application, you're plugging into the framework of say Android or iOS. and they run the run loop and they pass information to you. Whereas for Mac and also Windows and I think Linux as well, you can control the run loop. So you can say exactly when you want events to come. And the web as well, actually. The web is more like mobile, right? In the web, you add event handlers to all of the different widgets, and then um, you get called back when something happens. So it's the kind of reactive versus proactive is another way to look at it. But since we're right now just writing a simple application for macOS, then we're going to be controlling the run loop here. So let's go ahead and do that. So we're just going to spin forever in this. We'll do 4. Actually, one more thing which can potentially happen is that this can fail and NSApp can actually return null, or not return, this shared application property can give back null. So we're going to just guard against that, even though this will probably never happen. And we're going to say, if we get back our application, then we're going to go ahead and do all of this. We probably should do the same thing for the window, but we're not going to do that for the window because if we can't even create a window, there's nothing we can do. We can't even tell the user that something went wrong. So instead, what we'll do is we'll just hash include cassert, and we'll just assert the window was created. Probably we'll never actually get, if hypothetically the window is never created, we won't actually get here, I guess, because we're going to be trying to call a method on a null pointer. So maybe actually this isn't necessary. And my mouse is frozen. 1 second, guys. Okay, is it back? No, right now I'm using my laptop as the mouse and it's kind of frozen, which is not a good thing. Hang on. Okay, well, for the time being, I'll use my actual mouse. Okay. So actually, you know what? Maybe we don't need this. We'll get rid of that. But to make the event, to service the event loop, here's what we'll do. We'll come down. Let's write a for loop for that. And this will be the stupidest for loop in the world. It won't do anything. It will just spin around. Although, we'll also need to create a way to exit out of the for loop eventually. There we go. Okay, so what we'll do is we'll just say for now the condition is true, but to create the thing, what we have is our event thing, and the way we get events from the run loop is that inside of NS application, there's kind of multiple run loops that you can potentially create. There is a default created one, and we're going to grab that. So the way that you do that is we'll call the method on NSApp called, I think it's next event matching mask. This is the thing. And so let's look up what that is, what the arguments are. Next event matching mask. So what this does is it takes an event mask. For example, if you wanted, there's lots of events, right? You've got kind of the same as every, probably this is going to be really big. Well, you can imagine, right? You can have mouse events, you can have keyboard events, you can have timer events, you can have socket events, you can have thread events, you can have user-defined events. Basically, you can tell when you grab an event, you can just grab an event matching a certain mask. For us, we'll deal with, say, multiplexing events on our side. So with NS event mask, we're going to be using just this catch-all, which is any. So you can see, right, you can grab left mouse up, left mouse down, etc., 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 just to kind of poll for if any events have come. So we'll use event type any. There we go. Until date, you can, every event is timestamped, so basically you can just pass a date to say whether or not you want something before a certain date. We don't care, so we'll use NS event type any, and then our until date, we'll just pass date is nil, which means just grab any we don't care. The in mode, this is kind of the run loop mode. This is where you would say what kind of event loop you wanted to care about. For us, we don't care about, yeah, that's right, system run loop modes. We don't care about any of this because this is from a fresh application. We only care about the main run loop, so we'll just grab the default run loop, and that's, I'm not actually sure what connection objects are, but we just want to grab input, so we're going to use this. Probably connection objects is something that's like macOS related in some way, but I'm sure we'll get to that eventually. Might have something to do with this, but I don't know. The problem with Apple and all of their APIs is that they try and, first of all, Appkit, Cocoa, which is another name for Appkit and all of its associated APIs, for whatever reason, they decided to wrap what the operating system already gave you in this weird object-oriented Frankenstein API, and I don't understand it personally, but you know, it is what it is. I believe this was called in mode. Yes, in mode. So we'll set the run loop mode just be the default run loop, and then finally, I think the last argument was dequeue, and this is whether or not you want to peek or just, if you wanted to just peek the event without removing it from the event queue, then you would set this to be no. However, we do want to grab the event object off because we want to look at it. So we'll dequeue it and it will be yes. Cool. And now we will actually want to do this again. So if I only wanted to write this once, we'd write a for loop. But what I'm going to do instead is I want to introduce you to kind of the way that will be the architecture, the concrete way that we'll be writing this application. So one amazing thing that I personally learned from watching, studying Casey Muratori's Handmade Hero is that the single Unity build for C++ is maybe the best thing to ever happen to this language in existence for independent developers. And what do I mean by that? Well, as I mentioned last time, the way most C++ projects, C and C++ projects work is that they have a build system. And then in the build system, you would go through and you would tell the build system all of the source files that you would have, and you would then compile each source file into, do I even have, maybe I don't. It's like a drawer. No. See, on Windows, there's Paint, right? But Mac OS, I think, has Freeform. But Freeform, you can't draw. No. I don't think you can draw. You can only, put shapes down. So that's kind of lame. What does everyone use? It's like Draw.io. Can I draw? Where's a pen? I just want a pen. I just want to, draw online. That's all I want. Klecky. What is this? Yeah, good. We'll do that. Right, the way it works is that you have all of your source files here, right? And then you would compile each. And these are your .cpp. It's hard to draw with a trackpad. In our case, we also have .mm. You would compile these using Clang, or GCC is less letters to write, so I'm going to write GCC. GNU compiler collection. Okay. So you would then compile each and you get an object file. And what this is the machine code that is the components of a final executable. So you have your .o files. And then eventually, these would all be linked together. And that's a keyword, linked, with a program called LD, or LLD, or is it LDD? No, I think it's LLD. These are linkers, and what they do is they create your final, maybe we'll make this shine, oh no, give me the color. This is disgusting yellow. But it's like, holy, because it's the one true executable. And this will either be a .exe if it's on Windows, or it'll be a .out, or a .bin, or whatever executable format is. And then you would end up executing this file. This is the executable. Execute. Exact. Okay. This is how typically that you would write a C++ file, a C++ program, a big program. And like every program is just some manipulation of this, right? Even if you had 1,000 files, even if you're Google Chrome and you have 30,000, 70,000 files, everything eventually boils down to this, creates one massive executable. The problem with this is that it's weird, right? And it's weird like this. So inside of a C and C++ program, you have the ability to already do conditional compilation. So you can already go ahead, which is kind of what this is doing. These hash includes are conditional. And you also have like hash if. And you have hash end if and things like this. So you can choose which files you want to include into your program. And by having a build system, you're just duplicating that behavior. That's not good, because C and C++ can be a lot, I wouldn't say it's smarter, but if you lay out your program in a logical way, like the files for your program, in say like a source hierarchy like this, then this is like sufficient and necessary. And it's also what Python does, and other programming languages, even JavaScript does this, and Java as well, where the project files are what, embedded in the file system layout, and it's kind of logical. But that's kind of a lesser problem. The more dire problem is that compilers are slow. Like modern C and C++, modern C and C++ compilers are incredibly slow. And each time that you access one of these files, right, you're doing disk I/O. You have to open this file to read it. You have to dump this file to load or they have to open it again on this side to create an executable. Now, obviously, you can't avoid opening the source file. That's obvious. But you can avoid making these .o files. And the way that you do that is instead of having all of these single source files change into individual .o files, instead what we can do is we can just have each source file included directly into our main, our singular primary source file. So the way that you will, and we'll see more of this going forward, but instead of writing like .cpp, 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 which you can do, and then compiling them differently, we'll just hash include them. So if I had like, touch another source. If I had another source file like this, what I would do for this to be a single Unity build, a single compilation unit build, is we just hash include this. Another source.cpp like this. We just hash included, and then there's no need to fidget. There's no need to care about build systems and the weirdness around build systems, because the compiler will take care of this. And I think that's what this needs to be, right? There's just so many problems with having single compilation units like this that other languages have got right. But C++, they tried to fix it with their module with C++ 20 modules, but like it's an epic fail, because as is typical with the C++ community, they just made modules so ridiculously broken and unintuitive from so many layers. But that's a topic for another day. Look, the point is that we'll be doing a single Unity build, and doing Unity builds come with other benefits than just having a simplified build system. Now that all of the source code is seeable by the compiler, you can just do global program optimizations better than even leak time optimizations. And the way primarily that we're going to do that is, instead of writing, say, like, order, like using order main, or let's say another file function name, void, like this, right? This is a regular function. We're going to make everything be static. So everything will be kind of internal to this compilation unit. Again, not sure how much I should go into into the inner workings of this, but essentially, whenever you have the keyword static attached to a function, what it does is it will hide this function from being exported. It tells the compiler that this function will only exist within the inside of this source file, essentially. So if we start including every other source file into our primary single source file like this, then it means that every function that we write that doesn't need to be shown to the outside world will be completely hidden. And it just makes optimization opportunities grow that much more. So we're going to make everything be static, essentially, is kind of the point. And our first static function that we're going to make is we're gonna wrap this up. So I'm going to create a function. We'll call it static appkit next event, I guess we'll call it. So we'll just pull it out like this. We actually need to return something, don't we? We need to return whatever the event will eventually be. And we'll just grab this. Okay. So Appkit next event, what do you need to take? You'll need to take in an NS application pointer. That's NSApp. You'll need to take in maybe an event mask. What's the type of this? NS event mask. Maybe EV mask. So what's cool about C++ over C and why I continue to use C++ over C is default arguments I cannot live without. So a default argument is if we don't pass EV mask, then it will default to this. But inside of the function, we will use EV mask. I don't think we'll ever need any other date for our purposes, so we'll just do it like this. And the only other thing that we'll need is the in mode. So what's the type of this? You are, and it's run loop mode. So you can be out in mode like this, and we'll default that to be the default. This, and do we want to add an option for dequeue? Sometimes maybe we don't want to dequeue. I don't see why we ever would not want to dequeue, because we'll just, hypothetically, we would just cache it on our side. So I guess we'll just leave this hard code for now. So this is going to be our event. Can you please reline this, and we'll return EV. Boom. Okay. And C++ doesn't, for some reason, they don't allow you to have a trailing comma in function prototypes, even though you can have trailing commas in array initializers. It's very strange. Okay. Now we have our function here. We can just come down and simplify this. So yeah, we can call this appkit next event, pass in our app variable. Probably this all one line now. And then EV will be this again. Excellent. Okay, let's see if we finally get our window. Hey, look at that. We have our window. So actually, let me run this again. So if you notice, remember, we put this at 200, 200, and it ended up being here. Now, Appkit, because again, Apple is infinitely wisdom, in their infinite wisdom, they decided that the coordinate system for Appkit will be completely opposite to what most people or other frameworks use. So the origin is the bottom left corner, whereas Android, iOS, I think Windows as well, Vulkan, the origin is the top left corner. And the web as well is top left corner instead. So that's going to be an issue for us going forward, and we're going to have to face that. But that's the reason why we ended up being placed here, where now the origin here is in screen space 200, 200. which is this point here. But this should be 400 pixels by 400 pixels. Okay, we'll talk about pixels and kind of the thing about the pixels going forward as well. But what you may realize is that we can't actually close this. I'm clicking, that nothing is happening. And the reason for that is because Appkit, if you're going to run the event loop yourself, then you also need to dispatch events to the window manually yourself. See, if you had just kind of plugged into the Appkit framework like what they expect you to do with iOS, then this would quote unquote just work. But because we have complete control, because we know more about our application than Apple does, this will not actually do anything. So we need to go ahead and fix that. Here's how we're going to do this. What we're going to do is actually, you can get, so if I just rerun this quickly, and my mouse is frozen again. Okay. So on the title bar, the window has the title bar, and it has also references to all of these buttons. So we want the reference for the close button. So we're going to go ahead and grab that. Now the way that we grab this is, I guess we'll put it here. Order, we'll say win close button, like this. Oops. Now the way we can get this is it should be a property on the NS window. So if we go back and look at the documentation again, let's see here. Managing windows, da 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 da. Main status toolbars, we're getting close. We're looking for the, default buttons. That's kind of what we're looking for, I think. This might not actually be the one I'm thinking of. No, it's not. Managing title bars. Yes, this is what I'm thinking about. Standard window button. Returns the window button, we give window button in the window views hierarchy. This is what I'm thinking of. So we want the close button. Yes, I want you. So we're going to grab the button. So let's see, it should be window standard window button, and the button that we wanted, whoops. The window button that we wanted is the close button. Where is the, just close these. And it's window close button, of course. Cool. You can see this has all of the properties of the close button. But the one that we care about here is this. So we're going to come through and we have our event. I should say actually, okay, well, this will be part of our transformation. So the game plan going forward is that what we're going to do is we're going to, when the window is running like this, we're going to see if there's been a click on the close button. And if it has been, then we'll set a boolean to be false. And then when somebody clicks the close button, we'll set that boolean to be true. And then when it's true, then we will exit. Or we'll do something like that. Maybe actually we'll do it like this. So what we'll do is we'll say order window should close, or what we'll say actually is app should exit equals false. And then what we'll do is while not app should exit. Actually, we'll do it like this. Maybe not should exit to app should continue. We'll say it like that. So we'll set this to be true. While the app should continue, then we'll go through our events. Maybe eventually here we'll do like render. So one thing I didn't say is that if there are no events, actually EV will be null. So we want to continue servicing events while we have an event. But now we can go ahead and service the event. So like I said, we want to see, this should do the same thing, yes. So we want to see if somebody has clicked this button. So we need to see if we have not a click down, we wanted to see if there's a mouse up. Because if you click down and then you click up, most people think of the click as the releasing of the button. So we'll look for a mouse up event instead. So if the EV, I think it's type, yes. If the EV type is going to be an NS mouse event, or actually it could be a button event. I don't remember what the left mouse, there it is, yes, left mouse up. If the event type is a left mouse up, then we want to see if the coordinates of the click are in the coordinate space of the close button. So each button, each kind of widget in the Appkit view is inside of its own coordinate space. And the way Appkit provides ways for you to convert between coordinate spaces, I recall correctly, the way that you do it is we can say, well, first we'll just get the location is going to be the event dot location in window. And then I think you can do something like this. If you take the win close button and then oh, how do you do it? I think it's actually ns point in rect, like this. So this is just a function that Appkit provides. It does essentially bounds testing. Given a point, given a rectangle, it returns true if the point's inside that rectangle. Otherwise, it returns false. That's one way to do it. I think you can also do like, what I'm thinking of is the Windows close button. It's like convert point to view. Yeah, like this. And this would kind of do the same thing. I wonder, does it have an inside point inside? It does not. Anyway, because the location, the point will be inside the window, what we want to do is we want to see, is this location inside of the window close buttons. In Appkit, the kind of like position the position of a widget inside of its parent's coordinate space is accessed with this frame variable. And actually we can kind of see that. So if I just set a, 1 second. If I set a breakpoint and kind of stop here and we look inside, we'll do a win close button dot frame. You can see this is where the close button exists inside of the Windows frame. So the close button's origin is also, what's really weird is that View's coordinate spaces begin in the bottom left, but the Windows coordinate space, I think, exists in the top left. So I don't know why they swapped it around for no reason. It's weird. Point is that the close button is at 7.6, which is like top left, and it's 14 by 16 pixels wide. So if the point, let's actually put the breakpoint inside of here. And boom. So you can see the location, right? We clicked it on 14, 417. This is, actually I could be wrong. This actually may not be what I said, because now the point that I clicked, the Y, you can see is actually quite high. It's very strange. Look, the point is that we will have to do a test to see if the point landed inside of the button. But you can see, right, the x coordinates basically line up. Where was I looking for? I'm looking for this. Right, the x coordinates basically line up if the button starts at 7 and it goes to 14, then between 7 to 21, that's where the button exists. We clicked on 14, so it's close. The y coordinates, however, are not going to be the same, so we will need to flick that. But I think what we can do is we can say, how can we do this? Let's see, lock equals perhaps when close button, convert point. We don't have a view though. That's a problem. Convert point. Lock, and then from view is if you're going. We don't have a view. Let me see what this does. Okay, that's kind of what I was expecting. Yeah. So let me explain what we just did. So we grabbed the location from the window. We grabbed the location of the click from the window, and then what we did is we converted that into the coordinate space of the close button. And when you add this from view thing, it will convert from the coordinate space of one view to the window close button. However, we are going from the window, so there is no view. The window and the views are two different things. And you know what? We'll actually we'll keep it like this. So what we did is we converted the click into the coordinate space of the window close button. So now what we'll do is we can just test this. And if this is true, we can say app should continue equals false because we hit close. And then we'll see what happens. Will this work? Well, let's see first if we even enter this loop, if I've coded this correctly. We come here, we click. Oh, we hit it. So now we should exit, and we do. So we'll do that again. And boom. Cool. So now we can exit the window properly. Sweet. Okay. Awesome. So actually, that was probably not a lot of content, but it was a lot of kind of background information. What did we cover? We covered single Unity builds very quickly, even though we don't have any other source files right now. And we also covered making our window appear, making our window close, and just kind of talking about how Appkit, well, conventions around Appkit event handling. And we'll be adding more to this. We'll be doing more mouse stuff, primarily mouse stuff first, and then eventually we're going to need to type things into this app as well. So we will do key input eventually as well. But that's enough for today. So thank you so much for watching. Please leave a comment down in the comment section or a question. Again, I'm kind of targeting this towards people who maybe don't know that much about Appkit, don't know that much about writing in C++, don't know much about Apple, or maybe you do know and you're just kind of curious to see what people like me are doing. Either way, I'd love to hear back from you. So make sure you leave something down in the comments section. And yeah, I'll catch you next time. Thank you so much for watching, and take care.